Okay guys, so now let's move to question 8.2. So I'm just going to read the question as I did on the previous question. So the question says, calculate the magnitude of the net electric field at point P. And this question, it's allocated 4 marks. So guys, I'm not sure if you're able to see, but the question says calculate the magnitude. Remember, the word magnitude refers to the value. So calculate the value or calculate the size of the net electric field at point P. So guys, let's just check if we've got a formula sheet provided on this question paper. So we've got formula sheet. Now we need to make use of this formula sheet to choose the relevant formulas for this chapter. So guys, this is where you concentrate with regards to choosing the correct formula. So as you can see, we've got the formula for calculating force. This is the V, this is E, this is E, and then this is N, or the other way of calculating N is that one. So now we are not requested to calculate the force, not the voltage, not the number of electrons, but the electric field at point P. So now it's just a matter of us having to choose between these two formulas. Okay, so guys, it's very, very much important that when you're requested to calculate the magnitude of a certain unknown, you consult the formula sheet and check which formulas are available. From there, based on what you're given on the information, you'll be able to choose. Again, we've got the constants, guys. These are the physical constants. So you must at all times be aware that you've got physical constant, which you might find some values that you could need. So guys, let's see. In most cases, when it comes to this chapter, you might find that the constant that we normally use, let me see, I will tell you just now that K. Can you see Coulombs constant K, which is 9.0 by 10 to the exponent 9 Newton meter squared per Coulomb squared. So this is the constant that you normally use with regards to this chapter. And the other one is the charge on electron, which is negative 1.6 by 10 to the power negative 19 coulombs. So these are the two physics constant that we normally use in relation to this chapter. So guys, let's quickly go back to our question. I'll read the question for the last time and straight away start with the first question. So guys, they say calculate the magnitude of the net electric field at point P. Okay, so obviously this is the formula which is relevant to this question. Why this formula, guys? Remember, they're saying calculate the electric field at point P, and this is the formula that we have to calculate the electric field. Why specifically this formula? It's because I've just shown you that we've got constant which is given. We're given the charge from the statement, and we also have the distance. But because point P, it's experiencing a electric field strength as a result of A and B. Remember, it's between A and B. So that means we'll have to then use A and B to calculate the strength at P. Okay, so now what we calculate is now the net, which is equals to E of A plus E of B. Remember guys, Very much important again to note on this question. Let me show you something. Calculate the magnitude of the net electric field. I just want you to note that the net electric field at point P. So the word net, it means total. Okay, so this formula, it's not for calculating the net, it's not for calculating the total, but in most cases you are given a mark for that formula, which shows that you know exactly what the question wants you to calculate. So with you adding these two, it shows that you fully understand that point P, it's between A and B. It is therefore important that when you calculate the electric field strength at that point, you take into consideration the fact that it's between A and B. Okay, so you can just expand this formula to say this is K and then this is charge at A. Obviously this will be R squared at A, obviously from A in relation to P, plus K Q at B divided by R squared. Okay, so now guys, straight away we just substitute and punch on a calculator and see what we get when we punch on a calculator. I'm not sure where's my calculator, but I hope you've got a calculator, so I'll just guide you in terms of how to do it. So now we substitute. What is K? We've just noticed from the physics constant, the value of K, I remember it's 9 by 10 to the exponent 9. Okay, so what is the charge of A? It's there, it's 1.5 by 10 to the power minus 6. Okay, all over, what is the distance from point A to point B? It's 0.4. Okay, so it's 0.4 plus, you do the same, K, it's 9 by 10 to the exponent 9. And then what is the charge of B? It's negative 2.0 by 10 to the negative 6 all over. What is the distance from B to P or from P to B? So do you now notice that it was very much important that at first we analyze that statement or that given diagram and fill in all the missing information? So in that case, we're given a distance from A to point P. We had to calculate the distance from P to a charge B or sphere B, and the distance is 0.3 squared. Why 0.3? Because when you add these two, they have to take you back to that given total distance. Okay, so guys, if you've got a calculator, you just need to punch all of this and see what answer you get. Okay, so let me just quickly check my calculator and then I will tell you how to punch that on a calculator. Okay, there you go. So let's start, guys. You just do a fraction button, you open bracket, 9 times 10 to the exponent 9, and then you close the bracket, open 1.5 times 10 to the exponent negative 6, you close, and then you go to the denominator side, it's 0.4, you close, you squared, you go to the side, you add. Now we are doing this part. Follow the same procedure. Start with the fraction button, you open 9 times 10 to the exponent 9, you close, you open, it's 2 by 10 to the exponent negative 6, you close, you go to the denominator side, you open 0.3, you close, and then you squared. Okay, so the answer that we get is 284,375. Okay, let me see, it's 284,375. I'm not sure if you also got the same answer, guys, but if you punch all of that correctly, you should be able to get that answer. Okay, so now there's a way in which you can write this answer in scientific notation. So remember, the unit for this is Newton per Coulomb. Okay, you can write it as Newton dot Coulomb to the power minus 1 or as Newton per Coulomb. It's one and the same thing. So guys, I think for today's lesson you will be able to learn how to write a number in scientific notation. So this is how I used to do it. From my lower grades, I would just count, let's just count from this number up to that point there. So let's see, we've got 1, 2, 3, 4, 5. Okay, so that means this is the same as 2,84 if I round it to 2 decimal places by 10 to the exponent 5 Newton per Coulomb. Okay, so this is how you convert a number and write it in a scientific notation, and at the same time you round it to 2 decimal places. So the reason why I had to stop there is because I wanted to say 2 comma this number. Otherwise, if I stopped there, it was going to be a addition of 5 then 6, then it means it was going to be 0,28 times 10 to the power 6 Newton per Coulomb. Okay, but otherwise you should just write it up to that point. So now guys, this is how you score how many marks. Let me just check on the question paper. This question, it was allocated 4 marks. So I'm just quickly going to show you exactly where you score your marks. So guys, what I like about physical sciences is that for just copying the formula from the formula sheet, they give you a mark. So they are going to give you a mark for just writing that formula, and again they will surely give you a mark for correct substitution. So you substituted twice, they're going to give you 2 marks. I hope you can see exactly where you score your last mark. This is where you get your last mark. Guys, very, very much important. An answer with the correct SI unit is what makes you to obtain maximum marks. I'm not really sure of what they do if you don't write the unit, but if you don't, then it means this is not a complete answer. That number could mean anything else. It could mean liters, it could mean volume, area. For as long as you don't specify the unit, then just know you stand a very good chance of losing some marks. So guys, for now, you can just have a glass of water and get ready for question 8.3. So ladies and gentlemen, if you have watched this video this far, it's a good indication to me that you're actually enjoying this lesson, you're getting value in this lesson. So please do make sure to just join our community. If you are new, just hit the subscribe button, just like the video, and also share with friends. Otherwise, if you've got any questions, guys, please do feel free to just post your questions. It could be suggestions, comments, or whatever it is. You can just post on the comment section. So guys, let's quickly solve this question. Now we move to question 8.3, and the question reads as follows: a point charge of magnitude 3 by 10 to the exponent negative 9 coulombs. It's now placed at point P. The question says calculate the magnitude of the electrostatic force experienced by this charge. So this question is allocated 3 marks. Remember guys, this question paper, it's for grade 12 and it's posted on my Telegram channel. You can just quickly join the channel and access this question paper. That's when you'll be able to clearly see these questions. So This is one of those easy questions where we won't have to stress that much. We won't have to waste a lot of time. You know, guys,